Dear students, welcome to virtual classroom of Municipal Corporation of Greater Mumbai. I am Sreekumar. The class is for 10th standard students. Subject is mathematics. Let me begin the class.
Dear students, we are getting into a new chapter. The name of the chapter is Coordinate Geometry. I would say that coordinate geometry is a junction between algebra and geometry. In algebra, we studied about algebraic expressions and various tools by which we can resolve the situations in mathematics. In geometry, we studied about various shape, size, and various aspects of geometrical theorems. Where geometry and algebra meet is coordinate geometry. It is coming under geometry, but the graph of algebra, the equations of algebra, and further will come in coordinate geometry. That is the beauty of it. You will be getting the elementary information regarding coordinate geometry in this particular video. There are certain prescribed things that you should study and understand, which I will be explaining as per your syllabus and textbook. Distance formula, section formula, slope of a line, these are the aspects which is related with your concept of graph is explained in this chapter. You are very familiar with the number line. Number line help you to understand the concept of number system in a much better way. You must remember that when you studied number line first, it was just representing natural numbers, whole numbers, integers, especially rational numbers on number line. Later you studied that number line is not limited to these numbers. Number line is having every point defined, and you found that certain numbers which are classified as irrational numbers also can be represented on number line. This you studied in 8th standard, where you came up across how to represent root 2, root 7, root 5, etc. on a number line. Slowly you understood that number line is not simply for representing numbers. Number line, when placed in a proper way in a graph, it became the coordinates of the graph. So my dear students, every learning at every stage and every class is having its importance. Now at this moment you should recollect the number line. To make you recollect the number line, I will just show you how the number line was, or how the number line presented to you in your lower classes. To put the number line properly, I need a scale over here, because number line will be having a scale on it normally. It depends upon what purpose we have made the number line. Anyway, for my convenience and for your understanding, let me start from here. Representing this as 0, and I can say this is 1, this is 2, this is 3, this is 4, this is 5. It goes on like this. Here on the left side, -1, -2, -3, -4, and goes on. This way we represented number line, and it helped us a lot to understand, to make us understand the concept of number system in a better way. And if I represent on number line certain English alphabets, for example, if I represent this with if I represent this with -1 with a P, and here if I put -5 and represent it as Q, and 0 as O, and 4 as R, Then if I say that the points on the number line represents certain coordinates, for example, the coordinate of -1 is P here, the coordinate of 4 is R here. This way we studied. And if you think about the length of PQ, this length I mean, we will say the length of PQ or segment QR, the total length. All this we can bring out easily from a number line. In order to get the length of QR, you will simply count the number of units between Q and R. That will be the length of it. Then you found that if you are trying to find out the distance between two coordinates, you wrote it as distance between coordinates Q and R. If I say Q and R, this is Q and this is R, then we will subtract one from the other, right? We will say Q and R, we will write it as the coordinate of Q and R we know, and we will be writing the subtraction of R minus Q will be shown in the form of 4 minus minus 4. So in the case of Q it is 5 minus 5. This way we studied it and we got the answer 4 plus 5, which is equal to 9, and it is arithmetically true. 1, 2, 5, 6, 7, 8, 9. 9 units difference. Understood? These things you have studied in your previous classes. So we have a clear idea about the concept of coordinates on a number line, the distance between two coordinates. Understood? These are all coming under recalling your previous knowledge. Thereafter, we came across the next concept of number line or next use of number line. It was about using that to find out the location in a graph. You remember the concept of graph clearly, where we named this axis as y-axis, and for our convenience this as y dash, this as x-axis, this as x dash. We know that these are positive, this side is negative. We remember it. This side is positive and negative. Here it is positive and negative. All this positive, negative representation on graph and the axis concept was very clear to you. Suppose that in such a situation, if you mark some particular location on this graph and ask you to find out the coordinates of that location, that also is clear to you. I remember. For example, if you are asked to find out distance between 2 points on an axis, for that I have to consider one axis over here. Let me take this axis, which is both are positive. And if I mark over here, this is x dash axis, जो मैंने छोटा किया है. This is y axis, very clear. This is x axis, and this is y dash axis. Sorry. Y dash axis, and if I mark 2 points over here, mark A over here, and another point B over here, it is on the x axis at two different locations. As far as y is concerned, it is at 0. This can be x-axis may x1, but in y-axis it is at 0 only. This is at x2 and in y-axis it is 0 only, because we are moving on the x-axis. Suppose that if I want to get the distance between A and B, which I write like this, which you have studied before, you will write x2 minus x1. Correct? Recollect this point. Very important point for further understanding of this chapter. Let us think about another situation. The axis may be different. The axis I am taking is on the other side. If I consider this one as axis, this is y-axis again. This is x dash axis. Here it is x-axis. Here it is y dash axis. And if I locate 2 points over here on y-axis, then we know that x-axis it is at 0. So we will write 0 here and 0 here for x-axis. But for y, it will be y1 here, y2 here. We start from here. And if I mark these 2 points as Q and P, we will find out the distance between these 2 points, where Q is 0 and y2, P is 0 and y1. The difference, we know that y2 is different, hence we will write distance between P and Q will be shown as y2 minus y1, because x is 0. Let us think about a different situation. Here the situation is slightly different, because to find the distance between 2 points, if the segment joining these 2 points is parallel to any axis in the xy plane. So segment is not the distance between 2 points. If that segment joining this point is parallel to any axis, it's better I show you with a diagram. I'm taking this y-axis and x-axis as before. X dash and y dash are made smaller. And this is the line segment, for example. In this line segment, you can see that if I name this line segment as AB, the line segment AB is parallel to x-axis, correct? And if I think about y coordinates of the points A and B, as far as y coordinate of A and B, that I should look here then. And we know that it is equal. Y coordinates are equal in this case. Why? Because this line is parallel to this. The change happens only in the x-axis. So to make my assessment easy, I am drawing perpendicular from A and B in such a way that, let me draw perpendicular. These are perpendiculars now. When we draw perpendicular to x-axis, now we can see that A, B and these 2 points, which I can name as M and L, this altogether has become a rectangle. I can say a rectangle, ABML is a rectangle. Rectangle, you can understand, it is having 90 degree all all the angles. And moreover, we also know that AB will be equal to LM because I have drawn it perpendicular. But, so there will be 2 points here. There will be x1 here and x2 here, I can say. So if I think about distance between AB, if I have to find out, I will be doing x2 minus x1 like before. Correct? But to my interest, here x1 is there, here x2 is there, and there will be something which we can say as y1. It will be same here y1. This you should take care. If I think about here x1 and y will be equal to 0, here it will be equal to 0. These are all just basics to make you understand how these coordinates work in a situation. Understood? If I think of drawing another axis, here the axis was parallel to another segment which is parallel to x-axis. If I draw another one where my drawing is having axis or segment parallel to y-axis, then I have to draw perpendicular in this way and mark it. Let me do it. This is y-axis, this is x-axis, and like before I have a segment given. Let me name it as PQ. And here, as it is parallel to y-axis, and the x-axis component will be same. That means if I put x1 here, the same x1 I have to put here. There is no x2. But there is y2. y1 here and y2 here. This way the coordinate work. And if I draw this and perpendicular here like before, this is on y-axis and x-axis is here, and we know that x-axis will be 0. Y-axis will be having the same variation. Here it will be y1 and here it will be y2. The same way it is a rectangle. I can say quadrilateral PQRS is a rectangle. Right? It is a rectangle. If it is a rectangle, PQ is equal to RS. I am writing RS here. Then RS we can simply calculate by subtracting y2 minus y1. We can resolve it. Again, अगर घर बनाना है तो हम पहले उसका फाउंडेशन बनाते हैं, और घर तो बनाना है हमको, ऊपर ऊपर बना के जाना है, लेकिन पहले तो नीचे डिग करना पड़ेगा ना, वैसा है ये सब. Digging down for making foundation for your concept of coordinate geometry. Because if you are very clear about coordinates in a graph, now when I say that there is no change in x-axis, means it is because the segment is parallel to y-axis, बोले तो x में कुछ change ही नहीं है. This side you should remember. And if the data is on y-axis, then x-axis is equal to 0. ये concept to be clear होना है. Because these are very important. Because further you will be using formula to solve this. How is it? Look at this from your textbook. This is from your textbook. लेकिन अभी आप textbook नहीं खोलेंगे. अभी मेरा explanation, क्योंकि textbook बात नहीं करते. I will talk to you now. In the figures, AB is parallel to y-axis, जो हमने अभी study किया था एक situation. CB is parallel to x-axis. ठीक है? To find AC, fill the boxes given below. ABC is a right angled triangle, right? And according to Pythagoras theorem, AB square is equal to BC square. Sorry, according to Pythagoras theorem, AB square plus BC square is equal to AC square. We will find the coordinates of point B. तो ये B के उधर क्या लिखना है ये हम ढूंढने जा रहे हैं. देखने से मालूम पड़ता है लेकिन वो हमारा तरीका नहीं ना. We will try to find out mathematically. To find the length of AB and BC, when we think about CB parallel to x-axis, the answer is no. CB parallel to x-axis. In such a situation, y coordinates of B and when BA parallel to y-axis, what will be the x coordinate of B? चलो return जाता हूँ. What will be the y coordinate of B? This is B. This is y. The y coordinate of B on y, it is 2, correct? Then x coordinate of B, you have to count from here to here, that also 2. That means AB is equal to AB is equal to 3, which is here, this point, which is y coordinate of 3, of AB, minus that of B, which is equal to 2 and is equal to 1. And as far as BC is concerned, x coordinate, as far as BC is concerned, we are having x coordinate 2 minus, when it comes here, it is equal to minus 2, which is equal to 4. You got AB and BC. In that case, AC square is equal to AB square, that is 1 square, plus BC square, that is equal to 4 square, which is equal to 17. Total AC is equal to root 17. This is what I said, putting foundation. How could we write that AB is equal to 3, how could we write that AB is equal to 3 minus 2? The reason is AB is parallel to y-axis, so we will be having x-axis fixed over there, so naturally we will have y2, which is 3 minus y1, which is 2. How is that BC is equal to 2 minus minus 2? Because BC is parallel to x-axis. BC is parallel to x-axis, and as far as y is fixed wherever it may be, there is no change. So the difference will be x2 minus x1, 2 minus, this is x2. If you are not getting the grip of this, go back in this video and come back. That is why in the previous few minutes I showed you about in a graph when the segment is parallel to y-axis and x-axis, just explained few steps back. That should be thorough for you, else you will not be able to understand how these numbers came. Take a pause here if you want, and further you will continue immediately, not after. You will take a pause. For me, there is no pause. You can take a pause here, digest what I said, then restart. It will be good for you. Because we are getting into a very important concept hereafter. So this much should be thorough to you. Let me go ahead. It is about distance formula. The thing what we understood just now or did just now can be converted into a standard formula. Look at the figure 5.7 extracted from your textbook. आप बार बार टेक्स्ट में जाएंगे इसके बाद, लेकिन अभी स्क्रीन पे. As far as the point A is concerned, we know we can write x1 from x-axis, y1 from y-axis, some number. We are not bothered about how much it is. As far as B is concerned, we can consider x2 as its x-axis value, y2 as its y-axis value, which is here. These are the 2 points on, and we are having a line segment AB here, you can see. Now, we are thinking about the distance between AB, and we already applied AC square in the case of last part where Pythagoras theorem was applied, and we got some idea. We are applying it in a different way. From point B, draw a perpendicular to x-axis BP, and from point A, draw a perpendicular to AD, perpendicular AD on BP, the newly drawn this one. That means first you have done this, second you are doing this. So we get one more point here, D. We can name D as x2 and y1, the y-axis. y-x2, because x2 we have written same, it will be because it is parallel to y-axis. And as far as AD is concerned, we will keep y1 fixed because it is in the same point here. And x changes, so we will write x2 over here, x1 over here. We got everything just like our previous one. BP is parallel to y-axis, and as it is parallel to y-axis, its x coordinate is fixed, and it is x2 in this case, and segment AD is parallel to x-axis, so its y coordinate is fixed, and x coordinates vary from x1 to x2. Right? If you think about the distance AD, as it is parallel to x-axis, as y is, we are not bothered, the difference x2 minus x1 will be the answer. That is what is given here. As far as AD is concerned, this distance AD will be equal to x2 minus x1, and distance BD is equal to y2 minus y1. यही मैं एक step पीछे बताया था. Now if you substitute this in Pythagoras theorem for the triangle ABD, you will get an equation. Before that, I have to tell you something very important. Is it applicable always? I would say yes. Let me draw a rough axis over here. For any 2 points, you will have an x-axis, you will have a y-axis, and there will be a perpendicular. For any line, you say, any line you take, you can draw a x-axis line, you can draw a y-axis line to it, and you will get a right angled triangle. That means this is universal application in any graph. That means this formula, which is derived by substituting the given data, assumed data like xy, x1, y1, x2, y2, is a universal fact. So in order to get the length of a segment or distance between 2 points on a graph, whether it is on x-axis or y-axis, whether it is on any quadrant of this coordinate, you have to substitute this formula. x2 minus x1 whole square plus y2 minus y1 whole square. This formula is named as distance formula. Interesting situations can be solved with the help of this formula.
Now click on the subscription button below to subscribe the channel, then the bell button to get the notifications of the new videos. Thank you.